Hey brothers, today I am going to try and make a piece of digital art on Turtle Toy. It is a platform that I have used to make digital art in the past that is designed to create art for pen plotting robots. Um, I really like this platform, but I haven't used it in a long time. And so I'm going to try and make a piece and talk you through what I'm thinking about as I make it, and we'll see how it goes. This is Turtle Toy. I'm logged in. Let's make a new turtle. So you can see how Turtle Toy works is you've got your code on the right and then your drawing on the left. So let's go get I was imagining something with a lot of circles. So I've got a helper function, a collection of helper functions. Let's use this ellipse function. So this is a function that draws an ellipse, and let's just get that set up. So let's get some constants. And in order to draw the ellipse, we have to what am I saying? Ellipse. Um, let's say like 40 steps. So let's call it H and W. And then we need a theta, so let's call that, use the rotation variable, and then we need x center, y center. So let's just get those. Um, Need a semicolon because it's JavaScript. We've got two variables we're not using, so I'll delete those. We've got our variables. Each variable controls different things, so let's just make it wider with H, taller with W. That's a little confusing, so we can flip those. We've got our rotation, and you can move the center. So we've got one oval. Let's make a bunch of ovals in like a pattern and see how that looks. Let's make a grid of ovals. So in order to make a grid, usually I use two for loops. I make one for loop that is the x direction and one for loop that is the y direction. And this is our ellipse function. So if I just copy pasted it in, replace the x center and y center with I and j. Okay, so here's a bunch of ovals. They're kind of too big, but that's okay. So let's just make them smaller. Um, there you go. So you can see you've got your grid of ovals, your grid of ellipses. I should just keep calling them ellipses. You can see we can make them wider. That's kind of interesting. We can change the rotation of all of them. It's also pretty cool. I already got something that's like got some like simple beauty to it, I think. Okay, so let's add just a little bit of Perlin noise to this to try and make it be a little more interesting. So Perlin noise is an algorithm that generates smooth noise is typically how I think about it. And what that means is if you imagine like TV static, that is noise where um, each individual value is random. But with Perlin noise, the value is random, but it also cares about its neighbors. So it's never going to like be too jumpy. So you can see in this drawing that uses Perlin noise, um, it's random, but it's got like a kind of curviness to it. So let's go get my Perlin noise function and then also and copy paste it into this code. Immediately what I'm thinking is we can rotate all of them a little bit with some Perlin noise. So how I do that is I've got my generated Perlin, um, and let's add to the rotation. So let's do Perlin 1 dot get I comma j times, and then we have to scale it. Let's just try scaling it by 3 for now, and we'll see how that looks. That is pretty interesting. I like this already. Okay, let's increase. Let's play with some sliders. So we've got some important sliders here. We've got the strength that we're multiplying the purlin by. Right now we're multiplying it by 3. That's like how much the purlin matters. We also have the strength of the change of the purlin field. So right now I have it set to 1. Basically, this is how fuzzy looking, how granular looking the purlin noise field is. So let's make a slider for each of these and see how they change the way that this piece looks. This is the same as it just was, but if I increase the magnitude of the purlin, it's going to make the ones that have more effect by the purlin be even more affected relatively. Let's just turn it up a little bit and see what it looks like. So you can see it's like even more wavy. I bet we could turn up the magnitude even more. Let's say that it can go up to 20. That's pretty cool. All right, let's see what happens if I turn the magnitude down and make the size of the field more granular. So you can see now it's a little more random looking. If I turn the magnitude up, I find it just kind of looks like mush. And that could be cool too. See, we've got some like waves, all sorts of stuff. What happens if we drastically change the width or height? So if we turn up one a lot, each ellipse is getting longer, which makes the piece look fuzzier. I think this kind of reminds me of like combing like fur on like a big monster. Let's turn our magnitude up even more. We can see the fuzziness keeps warping. That's pretty cool. All right, I think I am happy with this as like a simple little piece, just like a warm up coming back to the tool. Well, goodbye, brothers. I hope that you guys found this at least a little interesting, and have a nice week. Bye.